here we have z is equal to x squared plus xy cubed minus x cubed y squared. You're supposed to find the first partial of z with respect to x, second partial of z with respect to x, first partial of z with respect to y, second partial of z with respect to y, and then partial of z, well, it should be z squared, or partial square of z, I mean, with respect to partial y, partial x. That means delta square z by delta y, delta x, and delta square z by delta x, delta y. Now remember, delta square z by delta x by delta y, delta x would mean that you find delta z by delta x first, and then you find the partial delta with respect to y of that which you did a while ago. Alright? So here, wanted to write all these down. Pause the video and try this question yourself. Alright, you're finished. What did you get for them? Let's look at these workings. We want the first partial of z with respect to x. So what we have, it would be 2x to the 2 minus 1, which is 1. So it's 2x plus, we're treating y as if it's just a number, so y cubed is just a number. So number times x, when you differentiate it with respect to x, you get the number itself, so it's y cubed, alright? Minus. And then, this with respect to x, as you know, bring down the 3 times x to the 3 minus 1. 3 minus 1 is 2. And y is just a number, so it's y squared. You're treating it as if it's just a constant, alright? So that's the first partial derivative of z with respect to x. What about the second partial derivative of z with respect to x? What that means, the one that you got with respect to x, you differentiate that with respect to x again. So 2x, when you differentiate that, you get 2. Plus, well, here, y cubed is just a number. You treat it as if it's just a number, so it's 0. Alright? Minus, bring down the 2. 2 times 3x to the 2 minus 1. And the y squared part, that's also a number, so it's y squared, alright? Of course, let's fix this up. Plus 0, can leave that out. Minus, well, 2 times 3 is 6, so it's going to be 6. X to the 2 minus 1 is just x to the 1, which is x. And then y squared. So what you have is 2 minus 6 xy squared. Alright? Let's look at this one now. The partial of z with respect to y. So here, this will be amount to 0 because you're treating x as if it's a number. Plus, well, we're going to have 3 times, we're going to bring down the 3 times x y to the 3 minus 1, which is 2, alright, minus, and then what do you have here now? Bring down the 2, there is 2 x cubed y to the 2 minus 1, which is just y. This part can go, the x plus, the 0 plus, alright? So, all of this is what you have. Now, what about this part, now remember, this here is just a statement explaining what to do when you have partial squared of z with respect to partial x partial y. Let's put it all the way out here. Alright. Now, the second partial derivative of z with respect to y means that you're going to differentiate this with respect to y again. Alright, you differentiate it the first time with respect to y, differentiate it again with respect to y. What do you get? Well, this will be, you bring down the 2, it's 2 times 3, x times y to the 2 minus 1, which is 1. But y to the 1 is just y, minus. Alright, here, the 2x cubed, all amount to just a number. So a number times y. This is really like y to the 1. And you bring down the 1. And then you say y to the 1 minus 1. You reduce the power by 1. So you get 1 times 2x cubed y to the 0. What will that amount to? Well, here it will be 1 times 2, which is 2, x cubed, y to the 0. But y to the 0 is 1. So that's what you have. But let's clean this part up. 2 by 3 is 6. So what you get is 6xy minus 2x cubed. Alright. Now, for this part, the second derivative of z of the z delta z by delta x, but this time with respect to y. Now remember, when you say the partial derivative, the second partial derivative, or delta square z by delta y delta x, it means you've already done the part on the right. You've already done the delta x, and you're going to do the delta y on the delta x, which you did earlier. Alright, so this is going to be the partial with respect to y of let's look for the delta x. The delta x, which was this. So you're differentiating 2x plus y cubed, 2x plus y cubed minus 3x squared y squared minus 3x squared y squared. That's what we're going to work on. Alright, let's make some space. Let's drag this down a bit. So you're going to differentiate this with respect to y. So what you have is the 2x part, that's going to, that's treated as a constant, so you get 0 plus, this is y, bring down the 3 in front, it's going to be 3y to the 3 minus 1, which is 2. Alright, minus this 3x squared part, you treat it as a number, 3x squared, because remember you're differentiating it with respect to y. As for the 2, you bring it down in front. So it's 2 times 3x squared to the y to the 2 minus 1, but 2 minus 1 is 1. So it's y to the 1, which is just y. Let's clean it up a bit. It's going to be 3y squared minus 326 x squared y. So that's delta square z by delta y delta x. Now let us find this part, part f. It's going to be delta square z by delta x delta y. So this means you're going to find the partial derivative with respect to x of, it's going to be delta z by delta y. which means the partial derivative with respect to x of, where is it? Delta z by delta y is this 3xy squared minus 2x cubed y is 3xy squared minus 2x cubed y. Let's checking back to make sure. 3xy squared by minus 3xy squared minus 2x cubed y. Alright, good. So we're ready to differentiate this with respect to what? To x. What are you going to have? Here, the 3 and the y squared are just numbers. It's x to the 1. So you're going to have 3y squared alone here. Minus. Now this is being differentiated with respect to x. So it's 3 times 2 x to the 3 minus 1 is 2 y. 3 2s is 6, so it's going to be 6. Alright, so 3y squared minus 6x squared y. So therefore, let's write them down, the e and f again. Delta square z by delta y delta x is equal to 3y squared minus 6x squared y. 3y squared minus 6x squared y. And what was delta square z by delta x delta y again? Is 3y squared minus 6x squared y. Alright? So, what you can say here is that the second partial derivative of z, or delta square z by delta y delta x, is equal to delta square z by delta x delta y. Alright? So, was that what you got when you tried? If not, I want you to write down the question and try again without looking back here. I'll see you in the next video.